everybody. Nice to see some of you again after London. I didn't bring any chocolates this time, so don't worry, I won't be judging the question quality. But I did do a diploma on soil during lockdown, so I'm very happy to be part of the People's Front of the Soil Association, for those who get the Monty Python reference. So earlier this morning, we heard about peatlands, mangroves. We didn't hear so much about grasslands, salt marshes, or other types of wetlands, but we did hear that there are significant natural carbon sinks, as well as sequestering carbon. They can also be sources of carbon dioxide and methane emissions. In the last session, we heard about bankable projects, and recently I was speaking to the Task Force on Nature-Related Financial Disclosures, TNFD, and they spoke to us about bankable science. And I think that's where GEO sits. We are a bridge between sustainable investments and an extensive network of scientists, technologists, and practitioners who are working on environmental insights and intelligence. And you'll hear this from some of our partners here. In this session, we're going to talk about one of our many initiatives, which is called GEO Wetlands. And there are some flyers for those who want more information. We've been working with the Ramsar Convention and UN Environment Programme, UNEP, on an inventory of wetlands data to plan and implement protection, management, and restoration efforts. So first, I would like to introduce to my left, well, he's the only man, but just to be clear, Andy Holden, who is the Investment Director at Artmore Ventures. And given the topics that we've been around this morning, I've kind of changed what we're going to talk a little bit. And I just want to ask Andy, what are the challenges and risks around investments in wetlands?
Yeah, so I think as we said, over the course of the morning, we've heard about all of the great opportunities towards investing in nature, and we're all kind of aware of that, so I want to gloss over that. When I actually get through that narrative and get down to deploying capital from investors into projects, it's really a question of risk management, and that's all that really matters in our job and my job that I spend all my time on, basically. So, showing to our investors that we can map and understand the risks and help them understand it, because the further away you get from the projects, the less your understanding of it gets. So you have to keep mapping this out, visualizing it, showing your investors that you can understand what you're going to be exposed to, what risks you can manage, how you can get rid of other risks, all of that you can do. So from our perspective, there's two core factors to that. There's quantitative and qualitative risks, really. The quantitative element of it comes naturally, I think, to Earth observation with NASA and organizations like that, where it's all about understanding the impact of what these projects are actually going to do on the ground and verifying and gaining confidence in them over time. So really, because what we're talking about here is sequestering tons of carbon and understanding and proving that we've actually got that carbon into the ground and that it's staying there over time. And we can do that with satellites, we can do that with LiDAR, we can do that with on-the-ground measurements and carbon accounting. It's complex stuff, but demonstrating that we've got that quantitative understanding of the quality of the credits through time is probably the core of what actually drives value in carbon credits for us, and that's what we're looking to get out of this. We're looking to deploy dollars and get out carbon credits, basically, from an investor's perspective. There's also a qualitative aspect to it, though, and it's all about the communities on the ground, the project teams that we're working with, and that's harder to measure and build spreadsheets and data and models around, but it's crucially important to get a grasp on that as well, which is why we need people like Marina Well from WeForest, for example.
Yes, thank you for the opportunity.
Maybe I'll just introduce you.
Yeah.
So Marie-Noël Kaiser is the CEO and co-founder of WeForest. And you are working at a community level in countries such as Senegal. And also we heard one of your projects in Malawi, I think, referenced this morning. What are your sort of monitoring and partnership needs, and maybe follow up on the community aspect that has just been mentioned?
Yeah. Yes, you just talked about the technology verifying the quality of the project. Actually, when you do that, it's great, but you need to be much more upfront in the project. When you develop a project, you need to find the right location. You need to identify the right soil. especially in mangroves. If it's very salty, then you're going to have a very high mortality. So it's prevention, it's due diligence, it's checking information before, and this is where technology can help us. We already deploy a lot of technology. We already, for example, do a lot of biomass study. We do deploy eDNA. We do eDNA, for example, on the biodiversity measurement to have a baseline and then to see eventually how we improve the biodiversity. We have flux towers in the project in Senegal that we mentioned, the mangrove project, to measure the greenhouse fluxes. And so we do have a lot of technology deployed with the help of GEO and with the help of NASA. The point is we can be much more efficient at selecting sites, at making choices of how we want to develop the project, and then obviously at measuring, because you guys will be able to connect us with other knowledge from other sources, and that's what you would bring. And I just want to emphasize our role as a non-profit. So WeForest is a non-profit developing project in difficult countries, in tropical regions, either with carbon certification or without carbon certification. We do both. And this is really hard work. You talked a lot about risk, and we talked about it this morning. It looks like a very abstract word, but the main risk is you've got to do it with and for the communities that live there. You've heard that before, but really try to understand what this means. Because if you don't do that in the projects that you fund, then you go wrong. Because eventually the communities won't take care of the restored forest, or might even rebel when they see this project being carbon certified and sold to make rich people richer and not bring them any benefit. If you do that, that's the end of your project. So you as investors have to be super careful that really the benefit sharing is as big as possible for the communities. This is about the project reputation and about your company reputation. We've seen recently on BBC some news about some projects that failed to do that, and then the price is very high. So I would really encourage everybody to look at that the communities are at the center of the project.
And do you want to just talk about Malawi, since it's already been...
Yes, thank you. So WeForest indeed develops carbon certified project, VCS and CCB, for example, in Senegal on mangroves, but also in Malawi. You talked with this morning, your name? Stuart, yes. Stuart mentioned the few species left of the Mulanje cedar that we want to protect. So take a minute to imagine how we do that, because we had to look a lot to find the few species, the few samples left of those trees. And now indeed we're working with the communities that are growing those endangered and almost disappeared pine trees, cedars, to plant them in nurseries. So that's great. But if you only do that, you waste your time. Because if we just go and plant new cedars in there, what's going to happen in 3-4 year time? What do you think? It's going to become firewood like it did before. Because in Malawi, the population pressure is so huge. It's one of the most densely populated countries in the world, that whatever grows is taken for firewood. So our job as foresters, which seems very strange, right? We're foresters. Well, our job is to develop economic models for the surrounding communities as an alternative to them taking and burning those forests. So it is a very complicated job. The easy part is the forestry. The complex one is what do you do with and for the communities? And there we're looking for top economists and also people that are able to manage the governance of those communities. So if anybody's looking to change career path, I would say this is there's a big future there.
Thank you, thank you. So Lola Fatoyinbo, who's a research scientist at NASA and part of Wetlands, you've recently been in Senegal. In fact, you might even have just come here from Senegal, I'm not sure. Can you just let us explain why is Wetlands important and how can these scientific insights from Earth observation support nature-based solutions? And maybe I'll just say the description we use for Earth observations is sensors in, on, and around the Earth. So it's not just satellites or space-based data, it's also in situ and models and things like citizen science. So it's a broad definition of those sources.
Yeah, and thank you. It's a pleasure to be here. So obviously, as scientists and as members of GEO and working for NASA, really the background of what we do is to provide the scientific insight that is used by all of you here to be able to support the investments and also all the implementation that is happening. So we provide the scientific backbone, we do the monitoring, and really the effort from the space agencies and from GEO is to really provide all of the scientific information that is used. We also do this on a different scale, maybe, than what is being done from the implementing partners. So we look at things often from a global scale. And I have a few slides and videos that I wanted to use kind of as a visual support for what we're doing. Obviously, we've all worked with satellite data. We've all seen the nice, beautiful images that are taken by our Earth observatories that are flying around the Earth right now from all of the different space agencies. We've all seen this nice global view of our planet. But what we're able to do as part of GEO and through our work at the space agencies and as scientists is to really develop models that can be used as the scientific backbone, but also be implemented for applications. And so here I'm going to show a fly-through, let's see, a video that highlights some of the applications of the data that we have. Here we have a 3D model of canopy height that was taken from the JEDI instrument, which is on the International Space Station, that allows us to see canopy height on a global scale, which is used, this is LiDAR data, which is actually used afterwards to calculate biomass and carbon stocks. And here, obviously, this is on a global scale. Essentially, when you look at this, the areas that are brighter show you very tall trees, and the darker areas show you maybe shorter trees, which are then used to estimate what carbon stocks are on the ground. But really, what we need to know as scientists, and the way that working with GEO and GEO wetlands in particular is really useful, is we're producing this data, but we don't necessarily know how it's used. We know how we as scientists are using this data to produce global models and analysis. But how is it actually used and implemented by people on the ground? We know that this data is actually used to help inform where investments are and what type of investments are done. And so I think that's where having the collaboration with GEO and working with partners such as WeForest is really useful. And so as Stephen, as you mentioned, I just came back from Senegal. I had really the pleasure of being able to go and visit one of the sites that WeForest is working in. And just to show you a little bit of a comparison of what we were working on before and how it changes over time. So I'm going to show you a fly-through, really a zoom-in that shows us the area in Senegal. So we were in the Saloum Delta. And here we're going to look at Landsat data over time. So from the early 80s, how we're looking at the change in mangrove cover over time. You see here that the green areas are areas where you have mangroves. This is what I am looking at on a daily basis on my screen. I'm looking at change over time. I'm looking at the data and where I think that it is changing based on my models and algorithms. So here we have a map that shows us areas of stable mangrove, so areas where we know there's mangrove. And then we have maps of what we called regenerating mangroves, so areas where you had mangrove before that may have changed and that is growing over time and becoming healthier, and then also areas of gain. So this is what we are mapping based on the data that we have. But then after going to Senegal and being on the ground, you realize that what you're seeing and what you think that you're doing and the type of work that we are and models that we're implementing are actually very useful, on the one hand, for helping inform the type of restoration and reforestation practices. But it also allows us to know what the actual questions are that people are interested in. Like the question that we got when we were in the field, the questions that we got and the needs that we get when we're in the field might be actually different from what it is that we think is needed. And so previously, for example, we were working very much on mapping, areas of change. But then when you're on the ground, and I'm going to show one last video here.
Can I just
yeah,
ask
go
you,
ahead.
do you think there's a mismatch between what we've been discussing here and in terms of investment and what you've been seeing on the ground? And how do we, and maybe you're nodding your head, maybe both of you can answer that.
I think not necessarily a mismatch, but I think what is really useful is to know what it is that, I think for us as scientists and people who are developing the methodologies and the data, it's really necessary to know what people are asking for. What do people need? And I think there are some standard products that we're working on, for example, change over time or biomass. And then we realize that when we do go into the ground, what people are really asking for. So maybe in some ways there is, I wouldn't necessarily call it a mismatch. I think that there are additional questions that maybe us as scientists aren't necessarily asking, or we don't necessarily know that this is what's needed on the ground, which is where it's so important to work with GeoWetlands and with the partners, because it actually allows us to have more insight into what is needed.
And did you have something to add on
Yeah,
that?
I think we need to know what the reality is on the ground for two things. One is for the investor to understand that he's not just buying a ton of carbon. There are lives of people in there. There's a future of a whole continent behind that. There's so much reality. I think that's what some of you were trying to say this morning. We need to decouple it from just carbon credits. That's very abstract. And the other thing is, collectively, we need to see how much we can push the restoration movement, because there were also discussions about there's plenty of money and there's plenty of practitioners like WeForest, so what's the problem? Well, there's plenty of practitioners like WeForest, not so much. There's a lot of opportunity that we're not supporting. I think we need thousands and thousands of WeForests to do the same at the same time if we want to get a chance to reach our targets, and we need to do it now. So we need to collectively see how to empower those communities from the ground. We as practitioners, where we can disseminate our knowledge, you as investors to take more risk and support things. As long as things are happening, I think the biggest risk is the risk of inaction. It's not the risk of doing something a little wrong. And that's what I would like to say, and that's why we need to look at the field, the reality. To go and plant one propagule of mangrove is really hard work. You got to take a boat, you have mud until here, and it's really not a work that any of us would enjoy doing, I can tell you. So just be connected to the reality. That's my invitation.
Yeah, thank you, and a very nice segue to my last video, which kind of shows you what it is like in the field. This was taken just, I would say, 3 weeks ago now, and so here you're seeing areas. You can see the tiny mangrove propagules there. Everything is flooded. We were there in the rainy season. It's flooded. And you see how much effort it must have been to actually go and be able to plant all of these propagules there on the ground. And the reality is that using satellite data, we don't necessarily yet see what is happening here on the ground. So this is why, because this is going to show up as water on a satellite image. It's not going to show up as vegetation. It's also really interesting, I think, and useful to know that if you go back, you see that there are different types of, in terms of canopy height, for example. You can really see that there are different times or efforts that have been done. You see different strata and canopy heights of the trees, highlighting that there have been plantings that have been happening over time. And we often think about the fact that, oh, we're going to use Earth observation to monitor what's been planted or to help us, know where we should be planting. But the reality on the ground is that people are planting where they can plant. They're not looking at their phone or a satellite image to know, oh, we're going to go in here and this is where it's been outlined and this is where I'm going to be planted. Plantings have been going on here for many years, and I think that it's really important for us to understand that the reality on the ground is different. You're planting where you have access, not where, in theory, you should be doing the planting based on a satellite image. And being able to take that into account is really, really crucial.
So I'll come back to that. Are there any questions from the floor? Please raise your hand if you have anything. Yep, the lady at the back. Well, and there's one right next to you with the mic. Okay, oh, you. If you can just like say who you are and where you're from so we get a little bit of context for the speakers.
Hi, thank you very much. I'm Samantha Lacey from Nature Metrics. We have the cuddly toys just outside. I'm really interested in what you can achieve through Earth observation because it's in real time, because you're actually measuring real outcomes on the ground. But I think the thing I'm further interested in is how you ground truth that. So how you go beyond tree cover to thinking about outcomes for biodiversity and what's actually happening to the health of the ecosystem underneath that canopy that you can see from the sky. And I suppose it's an invitation to maybe have a conversation about how we can use techniques like eDNA to combine with Earth observation data so that we have a sort of a holistic understanding of the health of the ecosystems that are represented by those images. Just wanted to ask for your reflections on ground truthing. Thank you.
Thanks a lot. Who wants to take that?
Thank you for your question. We already use eDNA indeed because it helps you baseline and then you see the evolution. So it's really sampling what is the diversity available in this area. So it's environmental DNA sampling. Indeed, it's a different level of, either you look at it from space or you look at it from the ground. And we need all of that, indeed, to become smarter. But then you also need support in how do you share that information, because we are an implementing NGO. We learn all of that. What do we do with our data? Well, fortunately, we're connected to the ETH Restore platform in Zurich, the Crowther Lab. So great people that are helping us disseminate and share that kind of information. We're working with you now and with other partners. So we need people just to connect us to other scientists and other implementers. Otherwise, it just stays there, it's not used.
And that's essentially the role of GEO.
Exactly.
Is to sit there. There's another question on the screen, and then I'll come back to the chap at the back. So someone online has said, it seems that investors are still reluctant to invest in ex-ante carbon credits despite risk reduction through improved technology-based monitoring. How can they be reassured? So guess who's going to get that question?
Yeah, we've alluded to it already, that it's still that early stage funding gap is missing, and we'll hope that's what Artmore are trying to do basically is solve for that. We use tech VC language almost nowadays in how we're talking to investors and saying that there's this seed, Series A, Series B funding that's sort of missing from the value chain. And once we've started talking about that language, and the thing that we're, again, talking about risk mapping and saying that you're still actually going to have a large element of risk when you go into these projects at the start. There's no actual point in hiding around that fact. You've just got to manage those risks, identify them, and set out milestones that you can work through with the investors and what they've, like how much literally dollars it's going to take to get through a project, to get through these milestones, and show them this is the track to de-risking it. And we do require a higher compensation for working earlier down the chain, and when we get further up it and we've got less risk on the table, then sure, it's a different funding thing. But showing those milestones and the dollars that they need to do it, we are taking Tanzania, for example, where we're looking at thinking that you're going to need, right now it's all about permitting, and it's $200,000 for lawyers to work on permitting for the early stage projects, and you help the investor, the LP, understand, right, okay, that's actually what my dollars are going to, and you break out each funding step for them in detail and say, like, over the next 5 years, this is where we want to get to. Because I think sometimes we just look at the headline figures around the funding, so you can think like, oh, okay, it's $5 million for a carbon credit project, for example. That's quite scary, intimidating, large volumes. What we do with our LPs is we break it down and say, actually, the bulk of the money is de-risked further down the chain. You would really be spending $200,000, $300,000 at the start to get project developers in who know what they're doing, to get the data involved, to get the correct legal structures involved, and these are the milestones that we'll work through. And so, just as I said, like getting back to risk mapping and milestones that you've got to work through, it is all about dollars and cents, really, ultimately, with LPs and investors. You want to show them what you're going to be spending and where your money's actually going to be going. So good budgeting, good understanding of risks, of how we help to solve that problem.
Great, thank you.
Can I add something to this? Yes, thank you, Andy. remember just before Marcel talked about the water cycle and how we look at things, and we should be looking at things with different lenses. If we just look at the carbon, yes, there is risk because it's a tree or it's a forest and it lives and there is risk. But if you widen your metrics, you don't just look at the carbon, you also look at the biodiversity, you look at the water cycle restoration, you look at the economic development of the community, then your risk is somewhat mitigated because you know you will have all those incentives, those benefits. So that's my invitation as well. Let's look at a wider lens, with a wider lens at the project rather than just the carbon focus, because that's why we're here, right? We're here about looking at how we embed the biodiversity in it. So let's look at more metrics.
So can I go to the chap at the back?
Thank you. My name is Fernando. I'm an impact investor, and my key investment thesis is around soils, regenerative agriculture. So I really wanted to understand, can you also use the same monitoring that you're doing to monitor farmland? And how far can you go into looking at soil biodiversity?
So I'm assuming that's a question for me. and I think also to follow up on the previous question, which is the reduction of risk, is that the aspect that we can do, what we can do from the geo aspect and from the space agencies, is to develop the methodologies that allow us to answer some of these questions that may not have an answer yet. So if we're trying to monitor soil, for example, how are we able to use Earth observation to understand what the health or the biodiversity of a soil is? We can't, there is no direct measurement of like soil health because often it's underneath a tree. It's very difficult to get to that point. But what we work on is to try to produce the algorithms and the methodologies that can help us in collaboration with in situ data. I think, also there's a question online here asking about how we can use ground truthing data. It's really crucial to combine the data from the ground truthing, from our scientific models and Earth observation together to try to develop the most accurate way of monitoring or measuring what it is that we're trying to measure, whether it's biodiversity or carbon, biomass, or soil health. And so I think the role that we play as scientists and part of GEO is to inform these initiatives and try to help reduce the uncertainty. We're always working on trying to better our models, reduce what we call it uncertainty and error, and you will call it risk, right? And so also knowing how the data is used is, as I mentioned, a really important question. And now to answer specifically your question about agriculture, yes, a lot of the Earth observing data is used directly for agricultural monitoring. I would say actually that agricultural monitoring is probably one of the most advanced applications of remote sensing and Earth observing data. And from a soils perspective, I think that there are many aspects where you can use this type of data to try to infer what the soil health is.
And I would just add, and I'll come to you in a second, I mean, we have about 50 different programs. So we have Global Agricultural Monitoring, GeoGLAM, we have GeoBON, a Global Biodiversity Observation Network, we have GeoLDN for Land Degradation Neutrality. So we have many of these different activities within GEO, within the framework of what we do. And if you listen to what Marie-Noël was saying about the wider lens and the integration activity, that's a challenge we have, is bringing together the community, looking at the risk, and then having that change over time inform all of that. So I think, is it Marcel?
Measure biodiversity in a different way, because a cloud produced by an organic aerosols coming from a healthy soil, a healthy biodiverse landscape. A healthy biodiverse landscape transpires a lot of water vapor. Can you measure the water vapor transpired by nature, by landscapes? And can you measure the organic aerosols? Because if you have those two, you have a proxy of the biodiversity, of the health of the biodiversity of the landscape. And then you also have a proxy of the cooling role of nature.
So we have evotranspiration,
Yeah.
but I'm not sure on the biodiversity side how.
So
But organic aerosols, you need to have you need to measure
aerosols,
the
yes.
organic aerosols.
Yeah.
The aerosols coming from biodiverse landscapes.
So there are many, many different types of satellites and Earth observations. You know, I specifically work on, you know, the land sector or the coastal sector, but there's on the atmospheric side and on the hydrology side many models and satellites and data that is being produced, including trying to better understand aerosols. So there, we can talk later, but I think there are many existing initiatives and measurements that could be at least used to infer such measurements.
So I see the boss lady coming towards us, so that means we're getting close. So I invite you all to have a look at the flyer, and please talk to any of us about geo-wetlands and what we're doing. And I have my colleague Madiha with the red jacket. She's also here as well from Geo, if you want to chat to her. So thank you all for staying, because I saw lots of people go out at the break. Thank you very much for staying. Have a fabulous lunch, and look forward to discussions with you over the next 24, 36 hours.